さて、ここからは Getting Started with AWS Lambda and the Serverless Cloud と題しまして、General Manager of AWS Lambda and Amazon API Gateway, Amazon Web Service Inc. ティム・ワグナーより講演させていただきます。Please welcome ティム・ワグナー。
Hello, Tokyo. Thank you so much for joining me this afternoon to talk about my favorite topic, serverless computing. And let's start by beginning to talk about what is serverless computing and how does it fit into the AWS portfolio. There are three different ways that you can think about compute. And they differ in terms of what they abstract. Virtual machines abstract the hardware. Containers abstract applications, software servers, if you will. And finally, serverless, the newest of the three, abstracts functions. It abstracts code instead of a particular container or machine on which that code runs. And you can think of it as an abstraction of the language runtime itself. Now, AWS offers compute services for all three of these. EC2 for virtual machines, our infrastructure offering. ECS, the EC2 container service to run containers, Docker. And our newest one, AWS Lambda, which allows you to run serverless compute in the cloud without having to think about infrastructure, and simply by giving us the code that you want to run. Now, how do you choose among these three? Well, it depends what you want and what you'd like to do. EC2 offers you flexibility. It allows you to configure the low-level machines, networks, and storage, along with the operating system, to have the most control over your compute environment. ECS is perfect if you want to take an existing container and run it as a Docker image. And it has the advantage of allowing you to build on your desktop and run it in the same way on the cloud. Lambda is a perfect way to do compute if you don't need to change the operating system and you're willing to let us act as your server. It's the easiest of the three because you just give us the code and then we can run it whenever that code is required. If you will, we do the heavy lifting and you just think about your application and business logic. So what we're going to talk about today are how you can build these new class of applications, these serverless apps, using AWS Lambda and API Gateway, along with other serverless offerings in the AWS portfolio. So I'll start by talking a little bit about the details of Lambda and how you program it. Then we'll take a look at some of the architectural patterns. Lots of different companies are already using serverless to bring things to market faster and to build their solutions and spend even less to compute in the cloud. And we'll take a look at some of those use cases, as well as some of the specific companies here in Japan that have already adopted Lambda and Gateway. Then I'll talk a little bit about some of the best practices for some of our most recently launched features, and give you some tips and tricks to get the most out of Lambda. And finally, we'll take a look at a demo where we deploy a serverless application, a catalog or inventory system. And not only will the application be serverless, but the deployment itself will also not require any machines. So let's get started. Why would you use Lambda? Lambda offers three primary benefits. First of all, no servers to manage. So you can stop spending time and energy designing, planning, operating, and maintaining all of the infrastructure required to run your applications. Second, continuous scaling. You can do 1 request an hour or 100,000 requests every second, and Lambda's designed to automatically keep up. You don't have to think about the details. And then finally, because you don't think about those details, you don't have to pay for capacity you aren't using. That means no more cold servers. You know, we hear a lot that the cloud is like a supercomputer. And while that's true, that's just the hardware side of the equation. How do you program at massive scale? Well, there are 2 ways to do that. You can be an expert in distributed systems, and plenty of the people in this room undoubtedly are, or you can use Lambda. Lambda lets you take business logic and run it at massive scale without having to think about the complexities of doing that. It keeps the challenge of infrastructure scaling separate from application code, and it lets AWS act as your ops team to make those fleet deployments and that scaling successful and running all the time, 24 hours a day. Now, we talk a lot about innovative technology at AWS, but one of the things I'm the most proud about with Lambda is how we've priced it. We allow you to buy compute in the tiniest chunks possible, 100 milliseconds at a time, so that you can use as much or as little compute as you need. You can think of it like electricity. You use as much or as little as you need to get your job done, and you never worry about having spent too much and not used it. Now, on top of that pricing model, we provide this very large free tier. So every month, every account gets 1 million requests and 400,000 gigabyte seconds of compute. That means, in many cases, small teams, development, even low-scale production can actually run for free with Lambda. So how do you use Lambda? There are a few simple steps. First, you put your code into a zip file and give it to us. And this code can be written in any of the 3 languages we support, Node, Python, or Java. And importantly, you can bring your own libraries. Even native libraries, even assembly code, will allow all of it. Then you decide to call your function. And we can help wire it up to other AWS services, and we'll talk about some of those design patterns shortly. Or you can call it yourself, from a mobile app, from the cloud, from anywhere you like. Now, there's one other piece of the equation here, which is the resource model. And you can think of this as a very simple speed dial. You can turn it down and save money, or you can turn it up and get the highest performance. And that dial controls all the resources: compute, network bandwidth, I/O bandwidth, and memory. And finally, we make it very simple to secure your functions by telling us who can call them and what they're allowed to do when they run. Now, inside those functions, you have access to the AWS SDK by default, plus any libraries you bring. And you can build them any way you like. So IDEs like Eclipse or Visual Studio, command line arguments, and of course any third-party systems and tool chains that you prefer to use. Now, one of the most important parts about the programming model is what we call its stateless nature. And by stateless, all we mean is that long-term data storage is placed someplace else, not in your code. So for example, you put user data and session data into Dynamo, you put objects into S3, but someplace other than the local disk. Because the next time your Lambda function runs, we might move it to another machine. And if you scale, we want to be able to start those containers for your functions very, very quickly. Now, having talked a little bit about how you use Lambda, Let's take a look at how customers are getting value out of serverless applications today, lowering costs and bringing their solutions to market more quickly. I want to talk about three different categories here. First of all, data and media processing, building scalable backends, and then serverless application ecosystems. And you just saw a quick example of that third one if you were in the last talk with Alexa Skills Kits. And so we'll take another look at how that can work and connect to different ecosystems. Now, when we launched Lambda, one of the first use cases we enabled, and it's still one of our most popular, is data processing through other AWS services. Services like S3, Amazon Kinesis, DynamoDB, and others. And the way this works is simple. You put an object into S3, or you write data into DynamoDB, and that triggers your code to run. And if you do that at low scale, your code runs at low scale. If you do that at massive scale, your code runs at massive scale. And the nice thing about it is you don't have to worry about that. So now you can build things like S3 buckets that automatically compress their content. You can translate or analyze video files, or you can take documents that are flowing into S3 and create indexes on the fly. All of that done very easily without having to stand up machines, maintain servers, or worry about planning for capacity. So let's talk about our second category, scalable backends. These often come in two kinds of applications. Mobile apps, typically where you're using the AWS Mobile SDK on the client side, that would be running on the phone or the tablet, or IoT devices. And those IoT devices typically speak MQTT protocol up to the AWS IoT service, which calls Lambda in turn. Then to build the compute part, of course, you upload a Lambda function. That looks exactly the same as an event handler. And typically you have some kind of data tier. So for example, you store inventory data or catalog data in DynamoDB or a SQL database that you access through VPC. And we'll see both of those are common patterns. Now, to take a look at our next use case, we have to add one more ingredient, and that's API Gateway. Gateway lets you host APIs in a serverless way. Gateway is to APIs what Lambda is to code. A simple, fully managed way to host them in the cloud. And API Gateway does the heavy lifting of scaling, securing, throttling, and authorizing your APIs for you. Then inside those APIs, you can decide which parts of your RESTful endpoints do what. You can call arbitrary HTTP endpoints, or, as we'll see here, you can call Lambda functions. And so the two of these services work together to provide a complete HTTP serverless solution. And here's what that looks like. So let's say you want to build a serverless web app. The back end of this looks much like the previous example. A data tier, such as Dynamo, a Lambda function, which can read the data and transform it, as well as write it in the first place. And now we're adding an additional ingredient, API Gateway, to serve up HTTP requests. And you can make those public, you can use authorizers on them, API keys, and so forth. That's the dynamic side of the content, and the static side's even easier. S3 already provides static website support, and so you simply use that optionally with CloudFront to do media caching. And now you have a complete serverless web app. And you can find examples of this up on our blog, and of course, in various books and other discussions. Now, the third use case that I mentioned is the one that we talked about in the last session, which is Alexa apps. And what I'm showing you here is actually going one step further. It's actually using two ecosystems. An Alexa app that uses Lambda to implement the skill, and integration with Slack to allow a team to communicate. And so what we did was we wrote a little bit of code that allows an Alexa to hear your voice, translate it into textual form, and post it to a Slack channel, as well as reading from that Slack channel and speaking it back to you. And so with just a couple of pages of code and about 2 hours of my time, I was able to take these two exciting ecosystems and glue them together. And that's part of what makes Lambda so exciting, because I didn't have to do any of the heavy lifting involved in running my own fleet, which normally would have taken me days to set up, allowing me to do in a couple of hours what might have previously been a week or more of development time. So now that we've talked a little bit about some of those architectural patterns, I'd like to talk about how some companies here in Japan are getting value out of serverless architectures. Canon is a leading provider of consumer, business-to-business, and industrial digital imaging solutions. Their innovative cloud printing service lets end customers just send documents from their mobile devices up to the cloud for printing. Canon used a microservice architecture, like you've seen in this talk, with API Gateway and Lambda in the design of that newest printing solution. Okasan Online Securities provides a virtual trading system for training users and accessing market data, and they actually power that with large volumes of real trading data. They've used API Gateway and Lambda to create that order management system, which sits at the heart of their architecture. And the most amazing thing about this to me is that they were able to deliver this in 1/10 of the time and operate it at 1/7 of the cost of a conventional system by using a cloud-native approach. RecruitJobs Townwork helps end users find their next great job on a range of platforms, including mobile devices. End users can search and find jobs with criteria like industry, location, and other specifications. And then Townwork uses a state-of-the-art machine learning algorithm to help pick the perfect recommendations for that end user. They've used API Gateway and Lambda to help connect the dots, hooking up the end user mobile device technology to their back-end systems that are responsible for the training data and extraction, including managing the large volume of clicked data coming from those mobile devices and entering the cloud. We've been really excited to see what customers have done with Lambda, and I'm sure the most exciting ideas are still out there. Now, for those of you who've already begun building serverless applications, I want to take a few minutes, talk about some of our recent launches here, and then highlight some best practices that you can employ in your own work. The team's been really busy since re:Invent, launching a variety of new features, and I want to highlight 3 of those for you. First of all, we've upgraded Node to the new 4.2 version. And this is indicative of our ongoing commitment to Node and the importance that that language plays. It was the first language we launched in Lambda, and it's still an exciting language that's growing rapidly. And we want to keep up with the Node community, making sure that we have versions that people can always use inside of Lambda. Stage variables are an API Gateway feature that helps you deliver different versions and stage them as you roll out versions of those APIs. Also in API Gateway, we've recently added Swagger support. So if you're a fan of Swagger, or if you use Swagger Hub to expose your APIs or collaborate together as a team around API definition, you can now use that capability even more easily with API Gateway and Lambda. Now let's chat a little bit about how you can use some of these new features to get even more out of the system. Schedules allow you to run your Lambda function at any point in time. You can run it at a point in the future, or you can set it up to run on a recurring basis. But it actually lets you do a whole lot more. For example, if you have a function that you'd like to keep warm, so you don't have the higher latency of a cold start, you can actually place it on a schedule. And with a very large free tier, you can actually execute that function an awful lot during the month without having to pay for it. You can also use functions to do things like polling a queue. So if you're using SQS or you're using RabbitMQ and you want to extract data from that, you can combine Lambda with a schedule and extract that data out of the queue. And you can run that as fast or as slow as necessary to consume the data as it's being produced. You can also do things like call one function from another. So once your timer goes off, you can easily fan out. Lots of interesting ideas here and design patterns around schedules. Now, another feature that we launched recently is versioning for functions. And versioning is really simple. It just lets you have multiple copies of a function that change over time. Each version individually is immutable, so you don't have to worry about it changing out from underneath you or out from underneath a client. So what happens if you actually want to mutate part of it? For example, if you want to separate configuration from code. And one easy way to do that is to have two different functions, one to represent your configuration data and one to represent your actual code, and you simply call one from another to get the config when you need it. You can also store that configuration data in S3 or Dynamo and then retrieve it whenever you want it. Now, a closely related feature of versions is called aliases. Aliases are like symbolic links, and they let you do things like roll back a Lambda function. So if you've released one version and you decide you want to go back to a previous version, you can quickly change what the alias points to by pointing it back to a version earlier in time. And the nice thing about Lambda is that we will take on the hard work of rolling that change out across our entire fleet. So all you have to do is change the alias. We'll handle all the hard work of shifting all the code around on all of those machines. It's one of the ways in which serverless makes your job easier. And now related to that is this question of blue-green deployments. So of course, you don't have to worry about getting code onto the machines. That's our problem. But you might want to shape traffic when you change your code. And one way you can do that is by creating a traffic shaping function. That's a Lambda function that decides for a given request whether to call the old version or the new version. And then over time, you can change that ratio to decide which version dominates the request stream as your users' requests are coming in. So lots of flexibility afforded to you by being able to use an additional function there and then having all of those functions automatically deploy. And now I want to chat about what was probably our largest feature to date. It's one of our most powerful features, but it's also one that has some complexity associated with it, and that's VPC. So first of all, a couple of basics. All Lambda functions run in a VPC, all of the time. So there's never a need to turn on security. They're always secure. But you might want your Lambda functions to run in your VPC. And you would do that, for example, to access relational databases, Elasticache, private EC2 endpoints, or other resources that you have inside that VPC. And once you've turned that on, you gain access to all the VPC features. So things like peering, VPN endpoints, private S3 endpoints, and so forth are all accessible to your Lambda function. Now, one important note here is that if you do nothing else, your Lambda function will lose internet access. And that might be what you want, because you might want it to run only privately. But if you do want internet access, you can turn on our managed NAT service, or install your own NAT instance in the VPC. So an important caveat to let you decide how you want that function to behave. Now, a few other best practices for VPCs. First of all, remember it's optional. Don't turn it on unless you need it. The ENIs that are used by Lambda's VPC feature do count against your ENI quota. So you need to make sure that your limit is set high enough to allow for the concurrency that you're likely to have with your Lambda function. Now, we'll manage those ENIs on your behalf. So if they're associated with your Lambda function, you don't need to delete or rename them. And we'll clean them up even if you delete your function or stop using it within a few minutes to a small number of hours. Make sure that you have enough IPs for your ENIs. And then finally, you should specify at least one subnet in each availability zone. This isn't a requirement, but if you do, Lambda can make your code more fault tolerant. Okay, so having talked about Lambda functions and some of their features, let's talk about how you'd put a whole application together, one that combines functions and APIs and possibly event sources. So there are a few different ways that you can do this. Two options that you've got today are CloudFormation and open source frameworks. CloudFormation, which we'll take a look at here with our demo, is a deployment technology that lets you deploy all kinds of AWS services and resources. And that includes both infrastructure as well as serverless. So we'll see an example here in a few minutes of using CloudFormation to deploy Lambda functions along with APIs and a database. Now, there are also a large number of open source frameworks, solutions like Serverless.com, which provide a client-side solution for this as well. And each of these works a little bit differently, but generally they allow you to decide what parts of your code go together, which functions or APIs are part of a group, and then they help you stage, test, and deploy those as a unit. Now, one of the challenges with the open source frameworks as they exist today is that they're purely on the client side. So once those things reach Lambda, we don't have any knowledge of the application or the collection that they represented. So last week, we announced a new open source project that we're going to be creating called Flourish. Flourish is designed to help grow the ecosystem by offering an application model that can be understood on the server. And you can think of it as a collection of Lambda functions and APIs that Lambda is aware of. And it'll allow us to do things like version not just an individual function, but your entire application. So if you have 10 functions and an API, we can roll all of them back together as a unit. And we'll be doing this as an open source project in GitHub, in the AWS Labs. And that'll enable us to collaborate with other open source projects, other vendors, and our entire ecosystem as we build out Flourish. Now I'm going to take a pause here from the slides and show you an example of using CloudFormation. So what you see on the screen here is the CloudFormation console. And this is the easiest kind of demo because all you need to do is press a button. So what CreateStack does is it takes a description of the application that you're trying to create, and it deploys all of the resources inside it and hooks them up together. And this is as simple as just picking the file that you want to run and then having that stack created, just a couple of clicks. Now this takes a couple of minutes to run, so rather than asking you to sit here and wait, I'm going to go ahead and show you what this looks like when it's done. And this is an example of what happens after a couple of minutes. We get a complete stack created. Let's take a look at what's inside there. So here's first is a sort of pictorial representation of that stack. And there are a couple of things we don't have to worry about here, like the roles, but there are three main pieces. A Lambda function that's going to manage inventory data for us, a Dynamo table where we're going to store that inventory information, and an API gateway function that's going to provide a public endpoint to it. So what does that look like in the form of code? This is our CloudFormation stack. You can think of this as a JSON description of the application that we're building here. And I'm going to highlight a few different pieces of this as we go along. So first is the Dynamo table. This part of the JSON describes the storage unit. In this case, I'm going to stand up a new Dynamo table, and CloudFormation will go ahead and create that table for me. Now, normally there wouldn't be anything in the table. We'll talk here in a second about how we actually get our demo data populated. The next piece is the Lambda function. So if you remember those design patterns we saw, we typically use Lambda as the compute tier, Dynamo or another database as our storage tier. This is the compute tier. And so inside that CloudFormation template, I have a choice of two things. I can either embed the code directly for a small function, which we're seeing here, or I can point to an S3 bucket if I have a larger function. For example, if I built it in Java and I have an entire class file. And then that third part that we saw in the picture is, of course, is the API. And this is the part where we're defining the different pieces of the API. And CloudFormation gives you two ways to do it. I'm showing you one here. The other one is to use Swagger, which is an open source representation for APIs and compatible with features like Swagger Hub. Now, I mentioned there's one last part. CloudFormation gives you the ability to run a custom function after the stack has been built. And that custom function is just a Lambda function that can do anything you want. In our case, what we're going to do is we're going to use that function to pre-populate Dynamo with a little bit of sample data. So what we're building here is kind of a very simple application, but also one that's representative of a real-world problem. It's going to store inventory information and then allow that to be extracted and returned through an API. And this function will actually put an item into that table for us. So now that we've seen the CloudFormation template, let's see what it builds. As soon as I log back in here. So here's the Dynamo table. When we run that stack, we get a table that is automatically set up for it. And I'll quickly show you the items here so you can see the one that we've pre-populated with that custom function. This is the Lambda function that we created. And you can see sort of the core of the code here where I'm retrieving items from Dynamo when requested by that API. So very simple code. And finally, here's API gateway. So here's a definition of a RESTful endpoint that's going to call that Lambda function. And then we'll go ahead and press test here. All right, let's try that again. So I'm going to give this a sample query string. I'm going to look up how many jackets we have, press test, cross my fingers for the live demo. And here we can see that the catalog has 99 jackets ready to sell. Now what's cool about this is we've just built an inventory system that can scale to tens or even hundreds of thousands of transactions per second. We did that without having to stand up a single piece of infrastructure. And we deployed it without having to open up a client machine or fire up a Jenkins pipeline or anything else. Everything about the deployment and the code from start to finish here has been completely serverless. And that's part of what makes this so easy and makes it so fast. we're really excited about this serverless trend. We think it's one of the most innovative ways for customers to create applications and deploy them faster than ever in the cloud. And the things that make serverless really work are the following. First, functions rather than applications are the unit of deployment and scaling. And that means that machines and containers are not visible in the programming model. You think about the code, not about where that code runs. The permanent storage is outside of the system. That lives elsewhere. In Dynamo, in S3, any place you want on the internet, but not stuck inside of a local hard drive. Scaling is automatic, and it's by request, not by machine. And that's amazing, because it means that you can never over or under provision capacity. In the same way that S3 scales to the exact number of objects that you give it, Lambda scales to the exact amount of compute that you need to do. And one of the great consequences of that is that you never pay for idle. There is no such thing as a cold server or a cold container when you're using Lambda. It's automatically fault tolerant without having to write any code or think about availability zones. And yet, we provide lots of flexibility. You can run any code you like inside it. Any kind of native code is just fine. And we give you metrics and logging automatically, so you don't have to do kind of those boring, heavy lifting parts of building your application, and can instead concentrate on the part that's differentiated and unique to your business. And so I invite all of you and your companies to come join us in this exciting serverless revolution. And here's how you can get started. First, if you're a product manager or a program analyst, go check out our marketing web pages where you can find more customer success stories and learn more about how companies are creating serverless solutions and getting value out of this exciting new approach. Those of you who are developers, you saw me briefly here create an example and just how simple it is to get something real up and going in very little time. So I invite you to go to the Lambda console, create a function, and run it. And remember, you can do that 1,000,000 times a month on us. That's simply you're a Lambda expert. So the next step, add an event source or use API Gateway to attach an HTTP endpoint to your function. That'll show you how powerful it is to start creating serverless applications that can connect to other parts of AWS and other parts of the broader ecosystem. And then with just a few lines of code, as I talked to you about and as you saw in the Alexa demo, you can produce mobile, voice, or IoT backends that have the ability to scale with just a few lines of code. It's a really easy way to get started. I also invite you to follow what we're doing with Lambda. This is a kind of really fun, rapidly changing part of the AWS lineup. And so we're constantly adding new features, as you've seen here. And we talk about that a lot on Twitter and, of course, on our forum postings. And so with that, I want to thank you for your attention today. I will also be out in the speaker zone for a little bit if you've got questions after this, and invite you to come chat with me there, and of course get started on your own serverless journeys. Thank you so much.
ティム・ワグナーによる講演でございました。